Consider the situation shown in figure. Suppose a small electric field E exists in the space in the vertical upward direction and the upper block carries a positive charge Q on its top. The frictional coefficient between the two blocks is mu, but the floor is smooth. What horizontal force F can be applied without disturbing the equilibrium? So here, horizontal force applied is F. Now, let's consider the motion of smaller block. So, smaller block. On this block, in this direction, there is tension. In this direction, there is force F. And when we pull this in this direction, then there must be friction, which will oppose the motion. So let's find out what is friction here. So friction in this direction, there is its weight mg, and here this is normal. In addition, since there is positive charge to here and electric field is in upward direction, so there will be one force in upward direction that will be equal to Q. Now, if we balance the forces in upward direction, so we get QE plus N equal to mg. Our concern is to get N equal to mg minus QE. So we can find friction, which is mu times N, that is mu times mg minus QE. This is equation number 1. Now, forces in horizontal direction. So applied force must be equal to tension plus frictional force. That is F equal to tension plus mu times mg minus Q. Now let's consider the case of bigger block. So on bigger block, there is tension in this direction and friction will be in this direction, but the two must be equal. So T must be equal to friction, and friction will remain same as we have found here. So tension will be equal to mu times mg minus QE. We put this value of tension here. So F will be twice of mu times mg minus QE. And that's our answer. Let's go to next question. A block of mass small m slips on rough horizontal table. Block of mass m, it is moving in this direction. Under the action of a horizontal force applied to it. One force is applied on it. Suppose force is there. The coefficient of friction between the block and the table is mu. Coefficient of friction between these two is mu. The table does not move on the floor. Find the total friction force applied by the floor on the legs of the table. Do you need the friction coefficient between the table and the floor or the mass of the table? So here, friction force between table and the block, mu mg is friction force. Now for table, we consider. So since table is not in motion, and when we apply this force in this direction, so friction force act here, Fr, and if we consider the case of the table, then on table, there will be friction force in this direction. So because of that frictional force, table must move. Since table is not moving, it means between the ground and the legs of the table, the same force is acting. So we can say that frictional force applied by the legs of table and floor is same. that is F equal to mu mg. Here, we don't have to consider the motion of the block, means calculation is not needed. Although we can do calculation like the friction force. So if we consider the motion of this block, so we can say F minus mu mg equal to ma, and then we can find what is A for the smaller block, but that is not required. A equal to F minus mu mg divided by small m. Now, in our question here, it is asked, do you need the friction coefficient between the table and the floor or the mass of the table? If we want to find out numerical value, in that case, all variables must have certain known values. Otherwise, there is no use. Thank you for watching.